Hi friends, good afternoon. Today we are going to discuss how we can represent different operators that you previously studied: divergence, curl, gradient, Laplacian operator, right? Different kind of operators, right? In Cartesian coordinate system, we already discussed what does it mean and what is the physical significance, that and all we seen, right? Now in Cartesian coordinate system, how it represent, that we have seen. Now in cylindrical coordinate system, in spherical polar coordinate system, how we represent these operators, that is very important, right? So before coming to representation, let me discuss first, so what is scale factors, right? So representation, our topic is representation of gradient, divergence, curl, right? In different coordinate system, right? So here, look here. So before that, let me see that scale factors. What is scale factors, right? This scale factors is very important. We studied a length element in different coordinate system. For example, in spherical polar coordinate system, what is the length element which taken? dl is equal to, right, dr, right, dr r cap plus r d theta, theta cap, right, and r sin theta d phi, phi cap. All right. Now scale factors means, see what is the coefficient of dr r cap? 1. So scale factor h1 is 1. All right. And what is the coefficient of d theta, theta cap? That is r. Then h2 is r. What is the coefficient of d phi, phi cap? R sin theta. Then h3 is r sin theta. So you know what is r theta phi in spherical polar coordinate system. So it's a small variation with its direction, right? dr r cap is the small change in length along radial vector, dr r cap. Suppose here some element is there, that is the scale factor. This is the small change in length. Maybe that length you can extend it to any value, alright. So that depends on this coefficient. But here coefficient is 1. Here coefficient is r. Here coefficient is r sin theta. Then first of all I am introducing a new concept, scale factor, right? That is 1 r sin theta. In case of spherical polar coordinate system, the scale factor is 1 r sin theta. Alright? Alright. Now the scale factor in cylindrical polar coordinates, how we define? In cylindrical polar coordinates, the scale factor is, how we represented length element in cylindrical polar coordinates, right? So in cylindrical polar coordinates, again dr r cap, right, r d theta, r d phi, phi cap, right, r d phi, phi cap, and along z direction dz, z cap. There we studied r phi z. In spherical polar coordinate system we studied r theta phi, alright. So here what is the coefficient of dr r cap? Again 1. So 1, right, h1 is equal to 1, alright. Now what is the coefficient of d phi, phi cap? That is r. So h2 is R. Alright. Now, what is the coefficient of dz z cap? Again 1. Alright. So, 1 R1. So, scale factors in spherical polar coordinate system is 1 R sin theta. Scale factors in cylindrical polar coordinate system is, right, 1 R1. Alright. Now, how we represent divergence, curl, gradient and Laplacian operators in spherical polar coordinate system and cylindrical polar coordinate system. Alright. So, see here. So, very simple. Look here. General expression I am teaching you first. Right. The gradient that you can generally express in any coordinate system, that is gradient is equal to q1 cap by h1 dou by dou q1, q2 cap by h2 dou by dou q2, q3 cap by h3 dou by dou q3. Right. Now, if you find a gradient in cylindrical polar coordinate system, right, what you do? In spherical polar coordinate system, what you do? Now, first you should understand, in spherical polar coordinate system, first I do. For spherical polar coordinate system, h1, h2, h3. What is that? 1 R sin theta. Right. Alright. 1 R sin theta. Now, what is q1, q2, q3? q1, q2, q3. That is the coordinate in cylindrical polar coordinate system. R, theta, phi. This only we required. Right. Now, what is gradient in spherical polar coordinate system? Gradient in spherical polar coordinate system for a function. So, suppose I am selecting a function in fr r cap, f theta cap plus f phi cap. Then I can write, alright. Then I can write I simply select a function f, right. So, gradient how we represent it? This is r cap divided by, what is h1? 1 dou by dou r plus, what is q2 cap? That is our theta cap. Then theta cap divided by, what is h2 r? That is dou by dou theta. Alright. Plus, what is q3 cap? That is phi cap. Phi cap divided by, what is h3? h3 is phi. Alright. Sorry. h3 is r sin theta. R sin theta. Alright. Dou by dou phi. This is the gradient in spherical polar coordinates. Now, this is gradient of a spherical function f. Then you put f here. Then that f you taken to here. Right. Now, if it is given like this, f r cap, f theta cap, f phi cap, then take r cap dot r cap is 1. Then here what come? Del f. Here dou by dou fr come. Alright. Its component fr only come here. Remaining not appear here. Alright. So, that way you can do. Right. Alright. Now, the same thing how I write for cylindrical coordinate system. Right. For a cylindrical coordinate system, right, h1, h2, h3. Alright. h1, h2, h3. That is 1 R 1. Alright. Alright. Now, what is the q1, q2, q3? coordinates, right? That is here r, phi, z. Then how we represent gradient? Here r cap by 1 into dou by dou r plus here phi cap divided by r into h2 is r dou by dou phi. Now here again here 1, right? Then z cap by 1 into dou by dou z. This is the representation of gradient in cylindrical coordinate, right? Alright. Now how we represent divergence? Alright, how we represent divergence? First we study in spherical polar coordinate how we represent divergence. Alright, so divergence, look here, this is the general formula, 1 by h1 h2 h3 dou by dou q1 h2 h3 v1 plus dou by dou q2. This 1 by h1 h2 h3 is common, then dou by dou q1 h2 h3 v1, right? Here dou by dou q2 h1 h3 v2, here dou by dou q3 h1 h2 v3. Now they proceeding some order. If you understand that order, it is very easy to remember. What is v1 v2 v3? Nothing. v1 is, suppose your function some v1 r cap, see you know in spherical polar coordinate r cap, v1 r cap, v2 phi cap theta cap and v3 phi cap. Like a vector, right? In Cartesian coordinate you tell 2i cap plus 3j cap plus 2k cap. Similarly, in spherical polar coordinate system, how we represent a vector? v1 r cap plus v2 theta cap plus v3 phi cap. These are the r cap, theta cap and phi cap are the unit vectors. Alright. So the components v1, v2, v3. That is this v1, v2, v3. Alright. Now in spherical polar coordinate system, I want to represent divergence. How we represent? See, first you write h1, h2, h3. What is that value? That value is 1 r sin theta. Now you understand what is q1, q2, q3. What is that? R theta phi. Now very simple, 1 by h1 h2 h3, that is divergence in spherical polar coordinate is, alright, how we write? 1 by h1 h2 h3 r square sin theta, r square sin theta. Alright. Now dou by dou q1, that is dou by dou r. h2 h3, that is r sin theta, right? h2 h3, that is r square sin theta, r square sin theta. Alright. v1, what is v1? That is v1 only, when the function given only we change, right? Then dou by dou theta into h1 h3, that is 1 into r sin theta, that is r sin theta. Alright. Into v2, sorry, here v2 also here, then bracket complete. Then the final term is dou by dou phi, here h1 h2, that is 1 into r, right? v3. This is the divergence. Now you can expand this sin theta cancel, because with respect to r sin theta is a constant, then sin theta you can cancel here. With respect to theta, sin theta unable to cancel, so you cannot cancel here, right? So this is the divergence. So based on the function given, we can simplify this. Alright. Now in cylindrical coordinate the same thing. How I write? In cylindrical coordinate h1, h2, h3, that is 1 r 1. Alright. And Q1, Q2, Q3, what is that? R, phi, Z. Then how I write this equation? That is 1 by H1, H2, H3, that is 1 by R. H1, H2, H3 multiplication R only into again 1 by R into dou by dou R of again here H2, H3, that means R, again R. Alright, then the function is V1, that means VR. Alright, plus next is plus dou by dou theta, because here you have to apply H1, H3, then dou by dou theta of dou by dou phi of H2, H3, right? No, H1, H3, that is 1 into 1, 1 only. Alright, then 1 V phi, right, plus dou by dou Z of, alright, that is what is the function? H1, H2, that is 1 into R, right, Vz. What is VR, V phi, Vz and all? If you represent V as VRR cap plus V phi, phi cap plus Vz, Z cap. Suppose a function V is given in spherical polar coordinates like this, then VR, V phi, Vz, that or V1, V2, V3, that all are component vectors of the different unit vectors present in the coordinate system. Alright? Alright. So this way we can represent a divergence. Now let us go to how we represent a curl. Right? Curl and Laplacian. That also we can see, then we can summarize the result and then we can do problems in next classes. Alright? Alright. So again see here, again a del cross V, right? You just look into the pattern following. In all pattern is very easy to remember. Del cross V, 1 by H1, H2, H3. Then first row H1 Q1 cap, H2 Q2 cap, H3 Q3 cap. Second one is dou by dou Q1, dou by dou Q2, dou by dou Q3. Third row is H1 V1, H2 V2, H3 V3. Now what is the del cross curl of a function in spherical polar coordinates? Then first you understood H1, H2, H3, that is equal to what? 1 R sin theta. Alright? Alright. Then what is Q1, Q2, Q3? Coordinates in spherical polar coordinate system is R, theta, then phi. Alright? Now substitute the values. See 1 by H1, H2, H3. Then 1 R sin theta. Then R square sin theta. Then H1 again 1 Q1 cap, that is R cap. H2 again R, then Q2 cap, that is theta cap. Then R sin theta. H3, that is phi cap. Alright. This is the first row. Then dou by dou R, dou by dou theta. These are the coordinates, right? Dou by dou phi. Now H1 V1, that is again 1, V1 is VR, right? H2 V2, right? That is, what is H2? R, V2 is V theta, alright? And R sin theta, V phi, alright? So this is the representation of curl in spherical polar coordinate system. Now we can simply represent a cylindrical polar coordinate system. In cylindrical polar coordinate system, what change you bring? H1, H2, H3, you make as 1 R 1. Alright? Q1, Q2, Q3, there vectors are R, phi, Z. Now 1 by H1, H2, H3, that is 1 into R into 1, that is R, right. H1 is again 1, right. Q1 cap is R cap, H2 is R, that is phi cap, and H3 is again 1, that is Z cap. Again dou by dou R, dou by dou phi, and dou by dou Z, right. H1 V1, that is VR only, 1 into VR. Now H2, that is R into V5, right. Next is 1 into Vz. What is VR, V5, Vz? If in cylindrical polar coordinate system a function given like this, VR R cap plus V5 phi cap plus Vz Z cap, one vector function given like this, what is its curl, what is its divergence, alright. So we should use this relation. So if you know the basic relation, basic equation, then if the distribution of charge or something given in cylindrical polar coordinate system, you can use, right, definitely, right. Magnetic field is given del cross B, right, del cross B is equal to mu 0 j. The magnetic field due to a cylindrical charge distribution, definitely we require this equation, right, to solve current density, right, mu 0 j. This is not j cap, this is current density, alright, alright. Now again the final one, Laplacian. How Laplacian operator we represent, right. Laplacian operator, what is the importance? Definitely you studied this relation. Which relation? Poisson and Laplace equation in electrodynamics, alright. See, del square V is equal to rho by epsilon 0. This is Poisson equation. So this rho is given, right, in spherical charge distribution. Then how you solve this potential? Then you require this operator, right. So Poisson equation is given, alright. So we require the representation of this function in spherical or a cylindrical polar coordinate system. Then to solve the potential or this kind of equation, we must need how to calculate a Laplacian in operator in different coordinate system, right, alright. Now see here, for example, so Laplacian operator for a spherical polar coordinate system, H1, H2, H3, that is 1 R sin theta, alright, and Q1, Q2, Q3, this is R theta phi, alright. Now substitute here, what is del square value in spherical polar coordinate system? That is 1 by R square sin theta, that means H1, H2, H3, R square sin theta, right, into dou by dou R H2, H3, that is R square sin theta by H1, that is 1, into again dou by dou R, right, plus this is common bracket, again dou by dou theta, right, H1, H3, that means 1 into R sin theta divided by R H2, right, into again dou by dou theta. You can cancel this R and R, right, plus again dou by dou phi H1, H2, that is 1 into R, that is R divided by R sin theta H3 into dou by dou phi. This R you can cancel. This is the representation of del square operator in spherical polar coordinate system, right. In cylindrical, now if it is cylindrical, what you do? Again you write H1, H2, H3, alright. That is 1 6 1. What is Q1, Q2, Q3 in cylindrical polar coordinate system? That is R, phi, Z. Now substitute here. Alright, substitute that values here. 1 by H1, H2, H3, that is 1 by R. Alright. Now dou by dou R, H2, H3, that means R, divided by H1, that is 1, into dou by dou R. Right, plus again dou by dou phi. Alright, H1, H3, that means 1, right, divided by H2, right, that is R, into dou by dou phi, plus again H1, H2, that is R, dou by dou Z of R, divided by H3, that is 1, into dou by dou Z. So this is the Laplacian operator representation in cylindrical coordinate system, right? Now this notation you write and get more experience, then definitely you remember this pattern. Alright, when we do problems in electrodynamics, right, we must require all these operators, right? Alright, now just we can summarize whatever result we have studied. Look here, in spherical polar coordinate system, this is the divergence representation, this is the curl representation, already we seen, and this is the Laplacian operator representation. Alright, we already seen. Alright, now in cylindrical coordinate system, this is the gradient representation, this is the curl representation, this is the divergence representation, this is the Laplacian operator representation, right? So, so here all you can see dou square f by dou theta square. So we not multiplied into dou by dou theta of R into dou by dou theta and all we seen. So expand all, you can finally write like this. Alright. So this need not by heart this result. The general formula in terms of H1, H2, H3, Q1, Q2, Q3 you remember. Whenever the function given, put there and find out the values. It is very difficult to remember all of these formulas. Alright. Alright. So this is about today class, and we will discuss more problems in next class. Okay. Thank you.